Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are continuing our discussion on the issues and challenges, that is lecture number 5. So, earlier we talked about few issues in VR, namely the technological issue and the psychological issue. Technological issue refers to immersion, psychological issue refers to the concept of presence. What these issues broadly refers to is that through technology we can generate sensory stimuli and our psychology helps us to perceive that stimuli. Now, there should be a match between them so that we are able to perceive the virtual world as real world without being able to distinguish between the two worlds. The closer we are to this goal, that is the goal of any VR system, the closer we are to this goal, the better immersive experience we are providing to the user. But there are other issues as well in VR systems. Let us have a quick look at those issues. Goal of any VR system is to create high degree of presence, or in other words to make people believe they are in the real world while actually they are in the virtual world. But there is a very interesting thing here. When I say that we are trying to make people feel that they are in the real world while they are actually in the virtual world, what I am referring to with the term real. Now, that is not as easy as it sounds. That answer to this question may not be as easy as it sounds. For some people, reality is gold standard, that is whatever we perceive, whatever we sense in the real world, that is reality. So, for those people, if we are making a system, then we should try to match the experience as close to our real world experience as possible. That is, we can say, the goal of a VR system for that group of people, as close to reality as possible. However, that is not the end of the story. For some people, when we are building real world, a virtual reality system, the idea of reality should be something beyond our lived reality experience. That means, whatever we are experiencing in our day to day life, in our so called real world, should not be exactly mimicked in the virtual reality experience. So, there the concept of reality should extend beyond our lived perception of or lived experience of reality. So, those people consider a reality in virtual reality to be something that surpasses our idea of reality. So, that should be the goal of virtual reality system for that group of people. Then, as a developer, if you are given if you are asked to build a system, how do you decide? It is not easy to decide. What some considers good VR system, because it is matching their sense of reality, may not be considered good VR system to some other group of people, because it is not matching to their sense of or their expectation of reality. Now, if you are surpassing reality, then that reality may be good for some people, but for others it may seem like a creepy or a difficult to comprehend reality. So, there is some confusion in terms of what exactly is reality. In fact, there is something called the uncanny valley effect. Now, this actually is an outcome of a scientific study which showed how a human user is likely to perceive an artificial object and how closely the user is likely to feel the object to be realistic. What this effect suggests? Digital representation of humans appearing almost real evoke feelings of unease or eeriness rather than familiarity due to subtle imperfections. Although here we are using the term digital representations, originally the study was done with respect to robots, but that idea can be extended to the digital world. So, essentially it says that no matter how hard we try to make something appear like a human or something appear realistic, there will always be some sort of feelings or unease or eeriness due to very subtle imperfections that might be there, which is not easily recognizable or perceivable at the very outset. Now, this idea is explained in this plot, which also suggests that the effect, the uncanny valley effect, is visible when the human likeness is reaching about between 70 to 85% of the similarity. So, this idea is illustrated in this plot. Now, there are two lines, as you can see, one dotted line, this one, and one solid line, yellow colored, this one. The dotted line indicates a moving object, whereas the solid line indicates something which is stationary. On the x axis there is human likeness and on the y axis there is familiarity. Now, near the origin we have industrial robots, which anybody can see as totally different from human. So, it does not matter whether they are perceived to be familiar or not, they are totally unfamiliar. So, that is one extreme. Now, as we move along the human likeness axis, essentially this indicates that we are trying to make the artificial object, or in this case robot, or in the context of VR it may be digital objects. As we are trying to make it more and more human like, the familiarity effect is also increasing for both object in motion and the stationary object. In both cases we can see that it is increasing, but up to a certain extent. In both the cases the increase happened up to a certain extent, then we can see that the familiarity started decreasing. So, for stationary object it is decreasing like this, whereas for object in motion it is decreasing more sharply. Of course, it is another way of telling that when the object in motion loses familiarity, that is pretty sharp as compared to when the object is stationary. Now, this decrease goes on for some time, although we are trying to increase the familiarity, increase the human likeness here along this axis. As you can see, we are moving towards the positive direction. However, the familiarity keeps on decreasing and reaching a minimal point, and then again started increasing, and after some time it keeps on increasing. Now, this region where the although human likeness is increased, but familiarity started showing sign of decrease, and the point where it started rising again, This is called uncanny valley. This is the region where, although we are assuming that we have made our object appear like human, but in reality what is happening is that due to subtle imperfections as mentioned here, the perception of that object to the user may be creating some feeling of unease or eeriness. That is somewhat counterintuitive, as you can see, and this region is typically when the human likeness reaches between 70 to 85%. So, this region is the uncanny valley region, where the likeness we have increased to a significant extent between 70 to 85%, but familiarity decreased. So, that is the uncanny valley effect, and it has its implications when we are trying to create artificial environment in virtual reality. Although we may assume that we are creating very realistic scenarios with realistic objects, but that realism may not be appearing to be realistic to the end user. That is the significance of this uncanny valley effect. So, here what it implies is that we are having a reality that is more, we are increasing our reality that is more and more human like figure, but we are not getting the desired perceptual effect. So, while creating a virtual reality experience, we should keep in mind that there may be uncanny valley effect, that is, we are trying to exactly match reality, but that match may not be always leading to our good experience. If it falls within this uncanny valley zone, then this our experience may start deteriorating. So, there is this trade off, how much reality should be good reality or up to how much we should go to give a good experience. Now, one thing is there, that is presence does not require photorealism. Other cues may be equally useful. So, we do not need to always create a, say in the context of our earlier discussion, we do not need to always create a human like object. There can be other cues which may help us achieve higher presence. So, in order to do that, a VR system developer or VR creator, content creator should consider few things. One is representational fidelity, one is interaction fidelity, and the third is experiential fidelity. So, what representational fidelity says or refers to? The degree to which the VR experience conveys a place that is or could be on earth. The familiarity with a place on earth, the degree to which the VR experience matches with that familiarity or exploits that familiarity, that is representational fidelity. So, at the high end, very good photorealistic immersive film as content can refer to high representational fidelity, that is we are using 360-degree video or images of the real world in our virtual environment, then that refers to highest representational fidelity. On the other hand, if we are using purely abstract and non-objective worlds, creating such worlds which are totally unfamiliar to us in our real world experience, then that refers to extremely low or the other end of the representational fidelity spectrum. Then we have interaction fidelity, the degree to which physical actions for a virtual task correspond to physical actions for equivalent real world task. This is again tries to exploit our real world experience. So, at the high end or one end of the spectrum, we have intense realistic physical actions for virtual tasks. So, we are doing physical activities in a real world to translate it to virtual activities in the virtual world. At the other end, no physical motion at all for virtual tasks. Say for example, we are sitting, but in the virtual world we are moving forward by button press. So, that is that refers to very low interaction fidelity. Then we have experiential fidelity, the degree to which users' personal experience matches with the intended experience of VR creator. So, a free roaming world with endless possibilities and every usage leading to different experience has low experiential fidelity, because that is not what happens in real world. Whereas, real world constraints put into the virtual world navigation, movement, interaction means more experiential fidelity. So, more closer the experience in virtual world is to the real world, the higher is the experiential fidelity. So, that is what we should consider. Along with immersion and presence, we should keep in mind the different fidelities, representational, experiential and interaction fidelities. And why to keep those things in mind? Because of this uncanny valley effect. We should be aware of this effect, and we should ensure that these fidelities are maintained to the highest degree possible, so that such effects do not affect our virtual world experience. So, that with that we close our discussion on VR issues and challenges. Let us move to the next part, that is AR issues and challenges. Now, in AR, as we have seen earlier, there are not much immersion is not a major concern. So, psychological effect is less important here as compared to VR. So, accordingly, the challenges are mostly technological rather than psychological. So, let us revisit the definition of AR to understand what are the challenges. This definition was given by Azuma in 1997. So, there are three requirements for any system to be considered as AR system. One is it should combine real and virtual world. So, virtual content should be overlaid on the real world representation. It should be interactive in 3D, in real time. It should be interactive in real time, and it should be registered in 3D. So, from these characteristics, we can say what are the, or we can get some idea of what are the challenges in AR system. So, first thing is combination of real and virtual content. So, we are getting a representation of the real world on our device, and we need to overlay digital content or virtual content on this real world view. In order to do that, we need suitable display technology. That is our first issue, an appropriate display technology. Of course, this is there in VR as well, but in AR also this issue is there. Interactive in real time refers to the fact that we should have or we should support suitable forms of interactions, so that the user should be able to interact with the digital content overlaid on the real world representation. This refers to different input devices as well as different input modalities. And finally, registered in 3D. It relates to the ability of a system to anchor virtual content in real world such that it appears to be a part of the physical environment. So, as we have discussed earlier, in simple words it means that whenever we are augmenting virtual content in the real world representation, it should appear at a suitable place rather than appear randomly, so that it mixes seamlessly with the real world objects. Now, to register virtual content in the real world, pose of the viewer with respect to some anchor in real world must be determined. Now, pose refers to two things, position and orientation in our context. So, unless we are able to do this proper estimation of pose or proper estimation of position and orientation with respect to some real world anchor in the virtual world, with respect to some real world anchor, it will be difficult or impossible to register the content in 3D. Now, this pose determination has one or two phases. There are actually two conceptually different things. Both can be done in one phase, or we can have separate phases for each of those. One is the registration phase. It determines pose of a viewer with respect to the real world anchor, that is the registration phase. Other one is a tracking phase. So, first we have registration, then we have tracking phase, that is one time determination of pose is not sufficient. As the user is likely to move with an AR application, we need to update the pose of the viewer relative to a previously known pose. So, essentially change of viewpoint we should update with respect to pose, so that the objects appear properly, the mixing of digital and virtual content, digital and real world content appears properly, suitably to the user. So, to summarize, we have two things, two stages rather. One is registration phase. At the beginning we do it when the user starts using the system, and then as the time progresses, as the user movements are there, we update the pose with respect to the current pose. So, these are the issues in AR. So, let us summarize what we have learned. So, we started our discussion with VR issues. There we talked about two major concerns, one is technological, one is psychological, when we are talking of VR systems, and these led to two major concepts. One is immersion, which is tied to the technological aspect, technological issues of VR. Other one is presence, which is tied to the psychological issues of VR. While discussing these issues, we also have noted that there is something called uncanny valley effect. Now, this effect tells us that although our objective may be to make environments as familiar to the user as possible with respect to their real world experience, sometimes this familiarity may lead to some effects, particularly uneasiness or creepiness in the mind of the user. So, we should be aware of this effect and to try to avoid that while building systems, VR systems, and in order to do that we should be aware of few things, namely representational fidelity, experiential fidelity and interaction fidelity. For AR, the issues are mostly technological, related to proper display technology, proper input mechanisms and technology, as well as estimation of pose at the beginning and during the usage of the system. So, that pose estimation and updation is popularly called tracking of the pose. So, the tracking technology, input technology and display technology are major concerns, major issues in AR. In the next lecture, we are going to take up another major concern particularly related to VR systems, that is cyber sickness. So, in this lecture we have talked about few issues, major issues. One more issue we are going to take up in the next lecture, that is cyber sickness, which has 3 parts. Our discussion will be carried out in 3 parts: the causes of cyber sickness, the measurement, how we can measure cyber sickness, and the mitigation strategies, how we can reduce or eliminate cyber sickness while letting the user experience virtual reality. So, these are the references that are used in this part of the lecture. You can go through them, they are good reads. With that, I would like to end this lecture here. I hope you have enjoyed and understood the concepts clearly. See you in the next lecture. Till then, goodbye and thank you. Happy learning.